So this question asks us to sketch the graph of the following quadratic functions below. Notice how the question asks us to only sketch the function so that they want us to draw the general shape of the parabola and the intersection point of each axis. You don't have to draw tables and note down each integer x and y values like we did in the last video series. And for this case, we'll be sketching the graph of y equals x squared plus 2x minus 8. So right off the bat, we can see that there's no negative sign on x squared, so we can already imagine that the function would produce a u-shaped parabola. The next thing you have to do is finding the intersection point with each axis. Essentially, you have to find the coordinates where the parabola of the function and the x and y axis meet. As you can see from the graph, the y-axis is the vertical line where the value of x is 0 in all regions, and the same goes to the horizontal x-axis where the value of y is 0 in all regions. So if we want to find the intersection coordinates of the parabola and the x-axis, all you have to do is have the quadratic function's y value equals to 0, because that would mean the function will be meeting the x-axis where the y value is 0. In this case, since it is y equals x squared plus 2x minus 8, the equation will be rewritten as x squared plus 2x minus 8 equals 0, because the 0 is substituted into y. Now the equation can be factored and you would get x minus 2 times x plus 4 equals 0. And just like that, we taught in Unit 1, one of the two products value would have to be 0 to obtain a final value of 0, so we can assume either x minus 2 is 0 or x plus 4 is 0, and therefore x could be 2 or x could be minus 4. X could be 2 or x could be minus 4. Because we know that these x values are on the x-axis, we can immediately conclude that their corresponding y values are also 0, so the coordinates of intersections are 2, 0, and minus 4, 0. The same would go for the intersection coordinates of the parabola and the y-axis, and as the function will be meeting the y-axis where the y value is 0, we'll substitute 0 into the x value of the function. So the equation will be written as y equals 0 squared minus 2 times 0 minus 8. And when you add all of them together, you'll get a y value of minus 8. And again, because we know that this y value is on the y-axis, we can reason that its corresponding x value is also 0, so the coordinates of the intersection are 0, minus 8. The next step is to find the vertex, which is the coordinate of the midpoint of the x-axis intersection coordinates and its corresponding y value. For this case, it would be 2 minus 4 by 2, and we would get minus 1. And when the function is y equals x squared plus 2x minus 8, and the x value is minus 1, the corresponding y value would be minus 1 to the whole squared plus 2 times minus 1 minus 8, and we would obtain the y value of minus 9. And sketching the graph is a cakewalk at this point. All you have to do now is plot those 4 points, 2, 0, minus 4, 0, minus 1, minus 9, and 0, minus 8 in the right graph, and connect them in a way that would form a U-shaped parabola. So we would get like this based on our workings. Something like this, yep. And if we compare it with the graphing calculator's output, you can see it's pretty accurate. To end this video, whenever you have to sketch a graph of any quadratic equations, first take a look at the value of x squared to see whether the parabola would be U-shaped or N-shaped, going up or going down. Then find the points of intersection for the function and the axis, and finally derive the vertex from the x-axis coordinates and join up all the points. And that's it.